Hello? Is anybody there? I'm confused. I don't know what's going on. I've lost my memory. Oh, hello. Oh, Creatix, who are you? Are you the proprietor of this room? What on earth are you doing? Excuse me, I'm trying to get your attention. Do you mind? Oh, what's that sandstone doing there? That seems to... Well, I suppose I shall head upstairs. Not much else for me to do. I don't know what all this infernal beeping is all about. Oh, Creatix, hello. Yes, no, I'm trying to remember exactly where it is that I am and what exactly... This is a lovely decorated room, and if you... Right, okay. Shall I just head up there, then? Okay, I suppose that's exactly what I shall do, then. Oh, this is lovely. Oh, a creeper. Not the most pleasant. And there doesn't seem to be anywhere else for me to go. Creatix, if you really don't mind, I would love to have some basic understanding of where I ought to be going. Okay, now I'm confused. That one didn't seem to work at all, which kind of upsets the entire premise of what we have going on here. So, do you mind? Oh, okay. Well, that seems to have fixed itself then, hasn't it? Lovely. Okay. Oh, well, look at that. Fantastic. All right, thank you. Yes. Hello. Terrible acting aside, welcome back to Minecraft Agoraphobia. Yeah, I just put this thing together because I think I don't know why that last one didn't work just right, but I seem to have gotten the hang of getting a little, I guess, dumbwaiter service or servant's passage for our robots in the corner of the area. Let me go ahead and pull away these paintings so you can see this is kind of the footprint of what we're looking at. Although if I go around the back, I can strip away some of this wool so that we kind of have a better sense of what we're looking at and how this works. So it was recommended in the comments that, hey, have you considered maybe just trying plain old sticky pistons as perhaps a better... Why is that powered? Where's that getting... I bet it's getting power from here somehow. Okay, some weird sort of bud powering situation. Here is the basics of what the backs of this look like. Let me walk you through the circuitry. So the one thing is that we have power coming in from wherever our power station is, going through here. So let me walk you through the basics of this door structure. So we have a sticky piston here that pushes a block in or out of the way. And if I throw some power at it, let's give it a torch, like that. Then, of course, it pushes the sticky piston down, and then it retracts. Now, if you give it a very fast one-tick pulse, though, then it manages to spit the block out and doesn't retract it, or when it's on the subsequent firing, it will pull it back, which is standard Redstone-y stuff. But you need a one-tick pulse to do that. Now, there is a block, the observer block, that will do a one-tick pulse. So let's just build this real quick. If we place down... a block and then block there and a sticky piston facing upward. Can I do that? Let's see. Probably not. No. Okay. Do another one. Oh. Ba-doom. Wait a second. Nope. I was thinking about that wrong. All right. Put this there. Sticky piston. Right. Okay. Yeah. Now with a standard pulse, it's not gonna work too well, but that's okay. We use the observer to watch this other block, and the observer fires off a one-tick pulse when it observes a change. So if I grab a torch now and toss this here, we can see. Really? Is this? Oh, right. Yeah, it just can't. It is getting the pulse. Yeah, there we go. And if I put the torch there, it's doing the same thing. And so that does allow the sticky piston to push out and then retract the block. So what we need then is some block that can update that the observer can notice, and ideally something that we can control via redstone, which, easy enough, a redstone lamp. So if we provide power to the redstone lamp, then hurrah. Now this doesn't work with just whether or not the block happens to get powered, because this is in theory a powered block now. If I put the redstone there, you can see that, and I can toggle the... so the state of that block, being powered or not powered, does change, but it doesn't do anything that will trigger an observation, which is a bit of a bummer. So we need to use the redstone lamp because this is one where the block properties themselves actually change, and so we can just do that. And this gives us a lovely way to toggle that door. Then the last thing that we need, just to make sure that this is flush and to make sure that we have the space, is to, so we have the microcontroller over here, and there's a reason for that. The reason is that we need to have the microcontroller available to be pressed, but we also need... actually, you know what? I'm wondering if we even need the capacitor. Yeah, no, we do. Because if I were to send, well, I mean, suppose you don't actually need the capacitor. We could just send a redstone signal this way. No. That's why we need the capacitor. We need the capacitor just because it is a block that will pass through our charge, our open computer's charge, but will also pass through redstone signal, which... There's nothing particularly special about the capacitor. We could use a charger block or anything else. It just has to be an open computers block because that way when we run cabling over here, we're not going, hey, it will share the power with the microcontroller. So the microcontroller sends redstone signal over to this block, updates that, and then this lamp turns on. We get the signal, and we fire off the 1-tick pulse. Then this switches the thing off, and the same thing happens in reverse. So I have a very basic little program. Let me zoom over here. And if we open this up, let's edit door.lua. You can see here, so when you're dealing with stuff on the SD card, you don't get the whole OpenOS stuff, so there are a lot of libraries that don't exist. So we had to kind of write our own sleep function. We said deadline is computer uptime plus some timeout, and then we repeat doing nothing until computer uptime is greater than the deadline. So I say sleep for 5 seconds, then set our redstone output on the back. This is require side stop back, but the actual number. We set it to full strength, we sleep for 5 seconds, then we set it to nothing, and then we turn off. Now, the reason we do that is that right-clicking on a microcontroller turns the thing on. And you know who can right-click things? That's right, robots. So that wasn't helpful. Then we have a demo script, and it's just basic movement commands. Let's go ahead and open it up. So os.sleep, we have call an enter function and a leave function and add some sleeps in there. And all we're doing is moving forward to underneath this microcontroller, then right-clicking in the upward direction so that we power it on. So if we go ahead and run this, hit demo, and all this robot is going to do, so first waits 10 seconds because we had that in there so I could work my way around into there. But after 10 seconds, this thing is going to go forward, and that's going to hit this. This waits 5 seconds and then sends a redstone signal out the back, which causes that to update. The robot goes in, hangs out, and meanwhile now this thing is turned off, but the robot is about to turn it on again. And yeah, for some reason, we still have redstone signal. The redstone signal hasn't decayed. I'm not sure exactly why that is. I wonder if maybe we need to have a little bit of a sleep after we turn the redstone signal off before the thing powers off, because I think maybe the redstone is getting stuck in a weird state because we set the redstone output to 0. Okay, well that time it seemed to work just fine. I don't know, it's a little buggy. Well, I'll play around with it. We'll come up with something that's a little more stable. But that's the basic gist, and I think this is something that we can incorporate into our proper system. So now our robot can, in theory, even with a 1-block floor, can navigate around just using this corner space. In fact, this is nothing. It's just there. It was there to block some light to make things look a little more magical. But that's all that our robot has to do. And then, of course, the robot came up here and flipped this switch to retract this piston and let us out. So, yeah, I think we have a cool design for a door and a passageway for a robot. And I'm very excited to hear what you think about it. Let me know down in the comments. Meanwhile, back in the real world, I have been a little busy doing some redecorating. So Shaky is over here. I have run Shaky, and unfortunately, Shaky manages to come over here, pick up everything in the box, and then get stuck standing in front of this chest. I'm not entirely sure why. We're going to have to try the script out again on another robot and figure out exactly what I seem to be doing wrong. But as far as another robot is concerned, we have a little bit of a problem. One, I've redecorated there. We'll talk about that in a moment. But also, Kodos is no more. You see, I have added... I was trying to figure out the best way to dispense of unwanted extra seeds. And so I've redesigned some stuff up here. But Kodos is no more. Kodos was lost to an experiment where we tried to figure out the best way of disposing things onto cactus. And it turns out that when we're perched right above the cactus, we can indeed throw stuff straight down so that it will disappear onto the cactus. But then also, when I go ahead and break the robot to pick it up, then the robot itself falls into the cactus, and Kodos is no more. So we're going with lava as our preferred destruction mechanism. But we skipped over kind of the redesign to our farm. So let's jump up and take a look at that. So you'll notice... Here's our new farm design, because it gives us an awful lot more land to deal with, and everything. So I've got some water under these pillars, and then we're using the same water flushing mechanism that we had for our mob farm. We're going to have a dispenser. It's just going to pop up some water here. Actually, we have dispensers now. We used pistons with water blocks in the walls with the mob farm, but here we can use dispensers, and if these all turn on, then the water all flushes down into this 4x4 area. We've got some signs there, which ensure that the water is not going to fall down into the, what do we call it? The powerhouse, the slaughterhouse? Yeah, water's not going to flood into the slaughterhouse. So all we have to do is fire up all 4 dispensers, flush the water, and then we have to go through and replant all of the seeds. But the interesting thing, I've also gone ahead and taken the liberty of running some cable kind of all along here. The interesting thing is how we want to do this. So my plan is that we can put a microcontroller, the same that we'll eventually use for our passageway. We can put a microcontroller under each of these with a redstone card and a tier 1 wireless card. Now, one thing you may not know, because it's not actually in the documentation, is that there is a tier 1 wireless card. A standard wireless card, which is tier 2, can broadcast, I think, up to a range of 400 blocks. The tier 1 is a very low range wireless card. It's 16 blocks. But hey, that's all that we really need. So here's my thinking. We have 2 charging stations down there now. We have 4 hoppers, and everything runs into a chest. We're also running dangerously low on sheep here because we haven't been breeding stuff. Because yeah. So the new hanging station here. We have these 4 hoppers that are going to run into this chest. We will have a robot here whose job it is to go ahead and do that kind of patrol route and feed everybody. We'll also build ourselves a drone and keep that drone on top of this other pad. Now, the reason that a drone is cool is because a drone is entity-based, which means it can actually pass through kind of any blocks that a player could pass through, namely these signs. So the drone can come over, grab some seeds, hop up there, and do all of the replanting. So that's kind of the plan, but we need to get to work on it because, at least we need to get to a point where we can get this going manually, because otherwise we're going to run out of power. So I have taken the liberty of pulling together all of the resources that we are going to need to construct our microcontrollers. And so this does, unfortunately, we only have the 1 robot right now, and it's a headless one. I mean, it doesn't have a screen, which leaves us in a bit of a pickle. I think we'll also, depending on, we'll have to take a look at the resources. Maybe we'll build ourselves kind of a tier 3, top of the line, best of the best robot, and we'll use that as kind of the one that we test for all the things, and then we can make more lower tier robots as the needs arise. So, okay. Microcontroller case, tier 1, a wireless network card, tier 1. This was added, I think, toward the end of 2017, and the recipe, which I had to get just from reading the recipe file, what? Oh, right, let me pop over to a crafting bench so we can actually look it up. Wireless card, network card, tier 1, and it's just 2 redstone torches, a microchip, and a card base. So you get the same thing, it's just a maximum range of 16 blocks, and I think you're also limited to only having a certain number of ports open. We haven't done any networking stuff yet, so that's not going to be a limiting factor. Once our drone pops up in the middle there, it can go ahead and broadcast a signal saying, hey, time to flush, and then all of the microcontrollers can respond and activate that dropper, and then the water will rinse everything down. So I'm going to go ahead and build these. I've got we're doing just a regular CPU, memory, redstone card, wireless card, EEPROM. Okay, one microcontroller cannot connect to external components, but it's got the redstone card, and that's all that we care about. Now, the one thing you can, let's verify this. We can craft, rather than having to disassemble, let me grab the EEPROMs. Rather than having to disassemble, we can write some stuff to an EEPROM and then get the new microcontroller out. So we'll go ahead and write some boot up script for this microcontroller, and then we can just craft it with those EEPROMs, and then we don't have to worry about disassembling, putting in a new EEPROM, and reassembling, which would entail the risk of losing parts. So I'm going to build up the other 4 of these, and then we'll get to it. Okay, so while those were building, I brought a computer up here thinking maybe we could use it for testing, but I forgot, hey, if we use a redstone card and a wireless card, then that leaves us no graphics card, so it's not like we can debug stuff anyway. So instead, I just plopped one of these down, put some redstone out so we can test whether or not it can turn on some redstone, and wire that up to power. Started going ahead and trying to write some stuff, but this screen is just too small. Let's go ahead and jump into the real world, and then we will push things over here. We're going to go ahead and open a new file called water.lua, and normally what we would want to do is we would want to say local redstone equals require component.redstone and local I don't know, whatever the network thing is. We're going to have to look at the API. It will something. But we actually don't get this require component. That's something that we get from running on OpenOS. And when we boot off the SD card, we're not loading the OpenOS operating system. So we kind of have to jump to a slightly more low-level thing. So let's jump into the component. Is it the component API documentation? Let's see. Right, okay, but there is this whole tutorial on writing custom OSs, that they need an operating system to function, blah, 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 blah. You even need an EEPROM. So we're not going to be writing our own OS, but we are writing something that exists on boot up without an OS. So it gives you an example here. So accessing components in the BIOS, you don't have the primary system for components, unlike an OpenOS. So you can't just write component.redstone.setout, you have to create a proxy. I don't know entirely what the proxy is for, but that's fine. So this is an example of, hey, component list redstone, and then call it and blah. So this gives us an iterator and blah, 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 whatever. We're not going to worry too much about why, because to be honest, I don't entirely understand all of that, but okay. Proxy component.list redstone. And then, yeah, we've got to call it. Okay, so that's how we get the redstone. So then we'll do something similar for network. We just have to figure out exactly what the name of that is. I guess it's modem, right? Yeah, okay. So modem equals, and we'll just copy the same line. Oops. Yank to the end, and there. Oops. There we go. Modem. Okay, so then if we look at the modem API, so if is wireless tells us whether things are blah. So we can open particular ports, and that's great. That's what we want to do. We can, let's see, we can send a message, but that's not what we want to do here. On these, all we want to do is we want to listen for messages. So we want to open up, let's say, true do, because that's the other thing with these BIOSes is that you don't want to end, otherwise the thing is just going to turn off, and we don't want things to turn off. So we have to make sure that we're in kind of this permanent loop. So we have to first, let's see, modem.open, and we'll open a port. What should we call it? 4723. We're going to open port 4723. That means we can receive stuff on there. Now, so broadcast, it sends a broadcast message and it's deliverable to all reachable network cards. Doesn't necessarily imply that those are delivered. All additional arguments passed along as data. Cool. So someone else can broadcast. And yeah, here is an example. Let's see. Event.pull modem message. Wait for a message from another network card. So this is an example of broadcasting. And and then verifies that, yeah, so open up a thing, verify that it's open, broadcast on a different port, 321, and then pull all of this information from event.pull. So we're going to have to figure out exactly how that works in BIOS land because we can't just require this event API. Okay, so first thing I did was just look at, kind of drone and stuff scripts, because those are all going to be running off of EU prompts, so they're not going to be requiring OS libraries. And we see an example here. This is inside local function find client, while true do local event equals blah, 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 computer.pull signal. And this will get kind of all the events, I think, that the computer gets. It's not going to categorize them. But then we can just compare if the event is the modem message and the port is the port we were expecting. And cool. So let's just copy some of that. Well, actually, so since we're using this 4723 and we're going to use it in multiple locations, let's go ahead and make that a constant. We'll say local. Listen port equals 4723, and then we'll open listen port. Let's just call it port. Whoa, that's not what I meant. Yeah, port G. Okay, and then while true, we'll say local event, something we don't care about, which we send by the underscore, sender port, and I'm gonna ignore the rest of it because I don't care. Computer.pull signal. Cool. And I don't care about the sender either, do I? Yeah. Oh, yeah. So in this case, the modem is sending stuff to, port equals port follow. We're opening port follow. Yes. Okay. Fair enough. I don't care about the sender in this case because I'm not going to send a reply message, so I'll just use an underscore there as well. At least I think I can do that. Let's verify I can do that. Function foo. Whoops. Function foo. I can't hit the end key. End. Okay. Then we'll say a underscore equals foo. Cool. And then a is null. Okay, so I can use the same keyword for things I don't care about. So I care that the event is modem message and that the port is the open port. And if those things are true, I'm going to assume that I received a message that told me I should dump water. Port equals port. And those are the only things that I care about. Then we need to do our redstone stuff. So we'll say redstone.set redstone.set output. And we'll need to give it the normally would say require.sides.up. I will go ahead and look up what that number happens to be, because all it is just it's like a 1, or it's one of the directions from 0 to 5. I need to double check what that actually is, but since sides isn't a library we can require, we'll need to just type it in manually, and then we just set the redstone strength. So I'll say set it to 16, and then we would want to do something like os.sleep. But we can't do os.sleep because we don't have that either. But that's okay. If we look at the code for Open Computers, this is actually what is in OpenOS. We can see where os.sleep is actually defined, and we can just copy from there. So this is repeat until blah. Let's just go ahead and copy all this, and then we'll make some tweaks as we see fit. I had to forget exactly how paste was set up in this VM. We'll just call it function sleep. Check arg. I don't know if that's something built into Lua, but I'm imagining not. Check arg. Foo. Yeah, okay. I'm imagining that just doesn't exist. So that would just crash. Or maybe it's something that exists inside the game or whatever. That's fine. Now, the only other thing is that this event is referring to that event library that we don't have access to. So I'm just going to replace that with a no-op. I think that's probably the best option. So what this is doing is it's saying, okay, the deadline is the current time plus the time plus whatever timeout was passed in, and then continue to do nothing until the current time is past the deadline. Okay, but with that done, let's go ahead and say sleep for, I don't know, 3 seconds. That should be enough time. And redstone set. Oh, actually, we don't need to. Yeah, we need to turn it on and then off right away. You know what? Let's rather than have this code that is not going to work in multiple locations, let's put it in one location. We'll say local up equals require sides dot up, and I'll replace that with valid code soon. So we turn the thing on, then we turn it off, because we're powering a dispenser. So that's going to eject the water and not retract it. And then we just do this again after sleeping for 3 seconds. And that is all that we have to do. Okay. Computer pull signal. Yeah, so it tries to pull some signal from the queue. If no timeout is specified, it waits forever. So this prevents us from, I guess, otherwise we'd probably spend a whole bunch of time hanging out in this loop, being lame. So instead, yeah, so they don't want you to use it. They want you to use event.pull, but we don't have event.pull. So we can just say computer dot pull signal for this timeout amount of time. And that should, in theory, make sure that we actually freeze and we're not just constantly looping over here. So we'll wait the amount of time that we're expecting to. We'll wait 3 seconds. If it somehow hasn't been 3 seconds, which it should be 3 seconds, we'll go ahead and loop in here again. But whatever, that should be fine. Or I guess if we get a signal in that time, then we'll start the timer over. But whatever, that's fine. Okay, I think this will work. So we're using pull signal here to get the, and this will hang out forever. It says if no time is specified, it waits forever, which is what we want. So we wait forever until we get an event. And if the event is a modem message, then hooray. Then we go into this mode of saying, all right, we're going to turn on redstone above us, and then we're going to turn it off, and then we'll sleep, and then we'll turn it on and off again. So we're dispensing the water, we're waiting 3 seconds, and then retracting the water. Okay, sides.up is 1. So that's done. And I think we should be good here. The only other thing to make sure is that this is less than 4 kilobytes, but it absolutely is. So let's push this thing up. Only one way to find out if this works. We will have to flash a BIOS and yeah, see what we get out of it. So I'm going to take this Lua BIOS out. We'll put this card in. And if we get out of here, let's just say flash water.lua. It's going to say, hey, insert the EEPROM you'd like to flash. When ready to write, type yes. And it says, please don't power down. And enter new label. I'm going to type water. And it says, cool, you're done. And you can remove that one and put in your old one. So let's try that. Now, and actually I wasn't thinking this through. I should brought these cables down alongside here. Bum, bum. There we go. But I need to, because the redstone signal is up top. So we'll have to keep an eye on that. But pull you up and recraft you with this. Okay. Getting some scary sounds. And it does return the old EEPROM, so you don't have to worry about losing things that way. All right. Plop you down and boot you up. And it does stay on, which is promising, right? It hasn't crashed. Let's put a dust of redstone on top. You know what? Actually, let me grab a piston real quick, just so we'll have an easy way of verifying that this works. So we've turned this on. It's presumably listening for a signal, and then if it finds it, it should power that. And we should be able to broadcast from here, because this one also has a wireless network card in it right now. So let's open up Lua console. We'll say modem equals require component dot modem. And if we look, modem is that. So we'll say modem dot broadcast. Oops. Give me the signature. Okay, so port number, what was it? 4723. 4723. And then data, we could broadcast whatever. Whatever. That's awesome. Okay, cool. So for broadcast, it goes ahead and picks up that signal. Okay, I have migrated this computer down here just to serve as our broadcast station for the moment. It has a graphics card and a wireless card in it. I have installed all 4 microcontrollers down here. They are all on, and they're all kind of directly below each of these. Oh, you know, actually, yeah, okay, I do. I have put water in all the dispensers. So in theory, all I should have to do would be to broadcast a signal here, and we should see this flash. So let's, oh, I forgot to put a keyboard on here. Let's do that. Boom. Perfect. Okay, so let's go. Oops, I have caps on. And modem equals require component modem. And actually what I want to, I'm going to OS sleep for 10 seconds just so that we can get down there and watch this thing happen. I also just want to. I should have used a easier to remember port 4723. Okay. So modem.broadcast 4723. All right. Let's 2, 3, 4, 5. Let's see how this goes. 10, and it should broadcast. Okay, 2 of them worked. Some of them did not. Why should that be the case? Okay, I have thrown power distributors between everything and rebooted everything. Let's see if this works. Come down here. We'll have an opportunity to watch this thing in action. That's so very weird. It only got picked up by that one. I wonder... Now, broadcast should hit everything in range. Let's try broadcasting again and see if it's... Yeah, no, that time it's hitting different ones. So that time, this one went. Huh. Let's try again. Something else flushed. Okay, it's just those 2. I wonder if this... I wonder if this is just a range thing. I mean, that'd have to be my guess, right? Okay, yeah. Broadcasting enough times managed to get them all to flush. So, okay, yeah, reading up a bit more. It does seem that the wireless strength, there is some randomness added to it. So I think they're simulating a little bit of signal strength degradation stuff, which I suppose is quite possibly the issue here in terms of particularly getting to items like this. But presumably then, if we have a drone that comes up from here, stands right in the center of these 4, and then spams the message, you know, it can spam it for 2 whole seconds to get all of them to flush, then we should be in a good state. But, yeah, I'm excited about this. This does seem to work. It seems to be a viable strategy. We will have to build ourselves a drone and a new robot. I guess we can reprogram the existing, our headless one to do the feeding rounds down in the slaughterhouse. But we'll want to get ourselves a beefy thing for the next episode for really a lot more experimentation. So I think that is going to do it for today. I will see you when we expand out our crew roster. And let me know what you think down in the comments, and I will see you soon. Cheers.